This is the NeuroCave Connectome visualization tool, and it has a brain tumor glioblastoma connectome data set imported in it. So the brain regions are represented as cube glyphs, and the tumor connectomes are represented as these spheres. So you can get a better distinction between them by changing the size. So by default, these scaling selectors are all locked, but we can unlock them with these check boxes and control all of them individually. So we can shrink the cubes to focus in on the tumor data set. Now the tumor data set is masked out in the raw data, and I haven't actually computed the connectome for the healthy brain tissue itself because I only had a single three-dimensional MRI image. There's no DTI or time series data for that. Although I took a random sampling of healthy data, when I did calculate the tumor connectome, the visualization doesn't show any connection edges between the tumor cells by default, but it allows the user to interactively on tumor regions, and it displays those connections, adjust their opacity, make it more visible. By default, it's in a threshold mode that's set that shows the connections that are stronger than a certain threshold. We can change it to a top N display cutoff set that shows the top 20 connections. If we click on this tumor, we'll limit to only the top 20 connections. So it has two linked views, and by default they show the same information, but there are some selection drop boxes that can be changed to configure the different sizes so that they can be compared. So now this one shows the MDS transform of the data. This on the left, and the right shows the anatomical coordinates of data, but they're linked. So any nodes that are touched in one show highlighted on the other. And also the color coding can be changed. So we can select the hierarchical clustering view, color coding. So now it shows the clusters. So the clusters are derived from the MDS coordinates. So that cluster together in the MDS transform are colored with the same color code as their positions. So this is a useful view here. You can see the clustering of the various tumor regions and compare them to their MDS coordinates on the left. Let's take a look at this red one here. So it looks like it connects those green ones. You can see it clearly on the MDS view and also in the anatomical view. We can also rearrange the nodes to really separate out the clusters into their own kind of artificially cluster regions that are just clustered together on the faces of a platonic solid. So that really shows the cluster memberships. So you can use this to identify the clusters very clearly on one view. And so you can click on all of these cluster members and see which anatomical regions they're targeting there. It seems like only these two tumors are involved. in those clusters. So we can hover around one tumor and see which clusters are contained in it, and the other tumor. And we can click on varying cells, various nodes in the tumor, and which clusters they're connected to. And this way we can fill in the edges of this graph and compare the cluster membership orientation of view of the graph with the anatomical translation of that, and perhaps gain some insight into the progression of this glioblastoma in this individual.